Here's pre-calc. It's problem 4-63. So 4-63 asks you to take this fraction here and rewrite it as something over x plus 4 plus something over x plus 1. Now this has been referred to as partial fraction decomposition, and we've only talked about it once. So, but this is a skill that you need for calculus. So the first thing you want to start doing is look at your denominator and see if you can factor it. And of course, when I took my denominator and factored it, of course it factored into x plus 4 and x plus 1. So I was very happy about that. The second step you want to do is to clear fractions. So what I did is I multiplied both sides by x plus 1 times x plus 4. And since we know that x squared plus 5x plus 4 is the same exact thing as x plus 1 times x plus 4, these cancel out, and it gives me a 1. And then when I multiply this x plus 1 times x plus 4 with this fraction, the x plus 4's cancel out and leaves me with a times x plus 1. And when I do likewise to the second fraction, the x plus 1's cancel out, and I end up with b times x plus 4. Okay, so the next step you want to do is we're going to try to equate our coefficients. So that's kind of new, something you've probably not done until this year. So what we want to do, this is actually the same as 0x plus 1. So you want to kind of get your x's together over here. And so to get this x and this x, like, I don't know, together, I need to get them out of the parentheses, so I distribute. And so now I've got two terms. This is 0x plus 1. I've got these two terms that have x's on them. So I just kind of rearranged it. See, and I put my a and 4b because I'm fixing to factor out my x. So did I show the factoring out of the x? Oh, I didn't even show it. So let me first, I didn't show all my work. So what I'm doing here is I see that these two terms both have an x in them. So I'm going to say that's x times a plus b. And these two terms, well, they don't have an x in them. They're just a plus 4b. But what I've done here is now I have a term that is like, it's like something times x. And I'm going to equate this term with the coefficient of x, which is just 0. Like the a plus b is the coefficient of x here. I could have written it as a plus b times x if I wanted to. So this coefficient equates with the 0 coefficient that's on my x. So that's why I wrote a plus b equals 0. And then this is just, this equates with the non-x term, which is just the constant. So I just wrote that as equal to 1. And then I'm just going to work these two problems down and do a system of equations. So this one, I just rearranged it. So I subtracted b on both sides, so I have a equals negative b. And then I thought that substitution is very nice in this case, so I took this negative b, see a, I substituted negative b in for a. I just substituted it right in. And then I said negative b plus 4b, well, that's 3b, and that's equal to 1. So b, if I divide both sides by 3, b is 1/3. So now I have b. And I know that a equals the opposite of b. So a is negative 1/3. And that's actually the answer for a and b. And then was I supposed to write them? Let me find that. It didn't ask me to rewrite them, because if I did rewrite them, I'd have some complex complex fractions, I'd have 1/3 over this, or I'd have negative 1/3 over x plus 4 and 1/3 over x plus 1. But it didn't ask me to rewrite it. It just asked me what are the values of a and b. So in this case, my answer is just right here. That's it.